Hello friends, welcome to my next tutorial on data wrangling tutorial series, the ultimate guide to data wrangling with Python using Rust Polars DataFrame to work with finance and supply chain data analytics. These are the topics we are going to cover in this series. In my very first video, I covered how to create finance and supply chain data using Polar series and Polar's DataFrame data structure. In second video, we learned about Polar's context and how to apply Polar context to view data. In third video, we learned how to apply basic expression over select context. In today's video, we are going to cover two topics, data type, costing and I/O. So let's get started. I want to call out that you'll find link to source code in video description below. And you can reach out to me at GitHub, Twitter and YouTube. If you haven't already, please consider subscribing to this channel for more videos. Let's open the Jupyter notebook we have been working on. So if you recall in very first video, these are a couple of the data frames what we created. Location, accounts, department, and we also created one ledger data frame which put it all together. All right. Now let's go create one more of ledger type equals to budget and combine these two. Now we have a complete data frame, ledger data frame, which has 100,000 entries. So in this section, we are going to completely focus on input and output. So let's start working with CSV format. So as you can see, the data from Polar data frame provide you a method called write CSV. Let's first just print out the couple of sample values here. As you can see, there are 200,000 rows, 100,000 for ledger type equals to actuals, another 100,000 for budgets. So let's call a method called write CSV on df ledger data frame and just specify the file name and the path where you want to write this file to. So let's run this. Ouch, I think there's some error. Let's go read the error. The system cannot find the path specified. The reason is because I have given a folder name and looks like that folder doesn't exist. So import OS and let's import the OS module. And the reason I'm importing OS module here because OS module lets you display the directory, the current directory structure. So os.list directory, as you can see, there's already a folder structure, folder created called downloads. If not, then you can always create a folder os.make directory downloads. Download. Let me run this. And now let's run this again. So df ledger.write CSV. What this function is going to do one more time is going to take all the df ledger content and going to write it to a file called ledger.csv. All right, let's go list out the content directory again. Let's say list directory and downloads. Let's read the content of the folder, say downloads. And here, if everything is well, you will see a file called ledger.csv. All right, so that's what it takes to create a file from your ledger data frame. Now what if you want to read a CSV file into a data frame? Similarly, there's another method called read_CSV. So if you run this, you will see it's going to read that. So again, 200,000 rows, you can see the speed. It takes like a fraction of seconds and is able to read that 200,000 rows into the data frame. All right, so you can do a before and after check to make sure that the data type or content doesn't change. One thing I want to call out, so there are some scenarios where CSV file is way too large that it can fit to your computer memory. So in that case, instead of using the read_CSV method, Polar provides a different method called scan.csv. So please take some time to read the content of this function. Scan_CSV is very similar function to the read CSV, but the difference is scanning delays the actual parsing of the file. And instead it returns a lazy computations. It's a lazy data frame. All right. So similarly, let's go, try to read that. If you see the difference, if you read the scan CSV, you will get a lazy frame. You instead of getting the actual data. So, and why do you want to do that? If you have a way too big of a file and you're trying to read that, you just want to see the glance through it, please try to use scan CSV instead of read CSV. All right. There's another data file format we want to work with is the Parquet. Parquet is another, just like write CSV, the methods are very similar. It's just a different file format. It's a very popular data format, and the reason is because way too popular. I can tell you that if you print 100 MB file in CSV, Parquet file is actually 10 MB. It's like 10 times less compression. So please, again the same method, write Parquet and read Parquet. Okay. So similarly, if you go list out the directory here, as you can see, it just created a Parquet file over there. So there are other, as you can see, the formats are, the methods what Polar provides is almost the same. Similarly, if you have a way too big Parquet file you want to read, don't use read_Parquet method. Instead, use scan_Parquet method here. All right. Similarly, it's not going to, when you use scan methods, is going to provide you laser frame. It will return a laser frame. Now let's go, try out this thing on two different file formats, JSON and NDJSON. NDJSON is like another newer method of JSON. It's like new line delimited JSON. Again, is getting very, very popular recently. Similar methods called write_JSON and read_JSON. Now, one difference I want to call it out here, there is no scan method on JSON format. There's only read method provided by Polar. Why? I don't know why. So, but just be careful when you're trying to read and write the JSON format. Similarly with NDJSON, same thing. Do not use a scan JSON. Instead, use read JSON file format. All right. Let's jump on to another scenario. What if you have a way too big file and you want to split that? So in that case, what you can do, you can just use the simple Python functions here. So for example, you want to split a big file in 5 different files. So for I in range, say 5, what you want to do, simply you say take the original data frame and you call that write_CSV method here, and you give like say my many files, and you give that part number here. Very simple functionality. So again, as you can see, let's go try to scan that as well, and you will see that it will create it. Now let's go list out the content of the directory, the download directory one more time. So if everything goes well, you will see there are 5 different files. .csv file has been created. Now let's go reverse it out. So for example, what if you want to read like those 5 different files into one data frame? So simply what you want to do, see that you will just say pl.read_csv, and you have to again create that, you just put a star. So my files _star, and this is smart enough to understand that there are 5 different files are sitting out there. All right. While we are on this topic input output, I want to cover one more scenario here. What if you want to read the content from the database? So again, Polar provide you direct support, a first class support to read it from the database. And we are going to cover this topic extensively in later videos. So in this case, I'm using a Postgre SQL. So again, define the connection URL here, and you can take the query. Query could be anything. Select start from query, and there's a method called read data place. Please take a minute to read the signature of this particular method. As you can see, it takes 2 parameters, query and the connection URL, and all it takes. So just provide the query equals to query, that means your SQL, and the connection URL, and you will be able to directly read the content of the database to your data frame directly itself. Again, these are the topic we are going to cover in later videos, but for now, let's say, and there are also, like you should be aware of, Polar provides some external connection libraries if you are working with external databases. We are going to cover this again in later videos. All right. So I think that's all I wanted to cover from the input and output section. Now let's go move on to another section now. Before we talk about data type costing, I want you to please go ahead and read this documentation, Polar data type documentation. And as you can see, they stated is entirely based on the arrow data types. So please take a minute to see what are the different data types available, like integer, unassigned integer, floats, and struct and list and those kind of things. This become very, very handy in later section when you're trying to convert the data from one format to another. So now I assume that you have gone through the documentation. Let's talk about the actual data type costing. So I'm going to go back to my previous notebook, and let's take the supply chain data model examples here. Let me run this data frame one more time. And the reason I'm doing it because there is a different type of data types we have been using in supply chain. So for example, I have a string, I have date times, I have float. So that's the reason I want to use this particular data set. Now let's read some samples here. So as you can see, this is a typical sales order. So most of the fields, as you can see, they are integer, they are of type integer 64, and there's one date time field here. Let's take a look at another example. So this is the customer data frame. As you can see, most of the types, they are a string, and some of the phone number, they're supposed to be integer, but they are a string as well. So we are going to see how we can use and the reason why you would want to do that, because more efficient data type casting you have, better your results are going to be. I can guarantee that. So Polar provides inbuilt functionality which you can use directly out of the box to cast one data type to another. Before we do that, there are 2 things you need to be aware of. When I say strict equals to true, so that means whenever conversion will happen, it's going to throw an error if it is not possible. If the conversion is not possible, it's going to throw an error. If strict equals to false, that will be converted to the null. Once you see that in action, it will be more evident to you. So now let's go take some example here. So for example, say DF order. I'm looking at a purchase order or sales order here, data frame DF order here. Let's read some samples from this. So something, I think there's some typo here. DF order. All right. So as you can see, this in the sales order, the ID field is of type integer. Most of the other fields like customer ID, item quantity, everything else is integer. Now, what we want to do here, so let's first select couple of the fields where we want to run some conversion. So let's take a look at the ID field here. So for example, what if you want to convert that ID which is of integer to float? There is no reason why, but just go with this. So for example, if you want to convert some integer value to float, that's how you do it. You just call the cast function and say pl.float, pass the pl dot and pass use the data type which you want to convert it to, and as simple as that. So now let's take another example here. So for example, quantity. Again, quantity as of now it exists as an integer value here. So what if you want to cast it? So just use the method say cast and pass the data type which you want to cast it to. So here now let's go run this. Okay, all right. So as you can see, previously it was integer 64, the quantity and ID. And if you scroll down, as you can see, those are now converted to the float values here. And by default, because you passed it at pl.float32, they are converted as the float32 data type. Now, what is the down casting? So for example, you have a too big of an integer, then actually eventually you are wasting memory. So you have only two ID number which goes from 1 to 1000. So it doesn't make to store those into integer 64. In that case, you want to store those values as integer 8 or integer 16. So let's take that ID field here, column ID, and you just want to say cast it pl.integer 16. And you give it a alias, means you are giving it a different name to that particular column here. Similarly, that customer, again, because customer, like, you don't need too big of integer 64 to store the customer IDs. Similarly, float amount at 1000, that's a very valid case. You don't want amount in integer, you can cast it to float here. So again, there's some error. Let me rerun this. Okay, because I didn't get the alias here. Okay, so here as you can see, so amount is now converted to the float, and float is small. That means you can convert a bigger data type to a smaller data type. That's called downsizing. Now let's talk about overflow. So overflow is just kind of a reverse of the downsizing. So for example, if you have a too big of integer and trying to fit into a smaller integer here. So let's take an example here. So we have got this float values which are in amount in thousands here. So here, for example, you want to take this field you want to convert it to a casting, which is not supposed to. So in that case, you use the try and catch statement here. All right. So let's take this value here, and I'm going to cast it to integer 8, obviously, which is a mismatch. So that's why I'm wrapping it inside and try and catch block. So and if there is an error, I want to throw it to an error. So as you can see, if read the error, it says this is failed by the value this. That means you are this data type is like overflowing. You cannot fit too big of a data into a smaller data type. All right. So now let's go, and that's what I meant by overflowing here. Okay, let's take another look at another example here. So for example, you want to suppress the error. As I said earlier, just use strict equals to false. So strict equals to false means what actually it's just going to suppress the error. So that means if the value cannot be converted, those will be just converted to the null. All right. So if you go back and see the result, see everything is converted to the null. I do not see a reason why you want to do that. That may you will have a loss in data quality. So please be careful when you use this strict equals to false. All right, so now I think that's all I wanted to cover from the overflow perspective. Now let's go jump onto the next scenario here. My next favorite data type is a string. So let's go see, what if you want to convert some, string to integer or integer to a string. So again, converting from numeric field to a string, I think that's it's 99% of the time it always works. Because most of the numeric values can be represented as strings. So here I'm just going to take the similar example here. I'm going to read all the fields except the ID, because I want to convert that ID was in integer. I want to convert that to to the string value here. So as you can see, I selected everything from DF order except ID. Now let's go take that ID field and run the cast on it. So cast, and here I'm going to say pl.utf format 8. So now let's go print this out. So if everything goes well, you can see the ID field at the last. It used to be integer 64, but now it's converted to a string value here. So as you can see, this was simple. It always works. But what if you already have a string and you want to change it back to the numeric? You have to be very, very careful about it. Like, most of the time, when actually if your string is holding actual integer value, 99% of the time it will work fine. But what if your column has a mix and match? Then in that case, it's not going to work. So in this case, you should use the try catch block, and you should start using those strict equals to true and false. If you have a mixed data type, so you can use the strict equals to true or strict equals to false depending on your requirement here. Now let's take a look at this example here. So here, as you can see, very simply, I am displaying the date in 3 different formats: date as a date, date as an integer, and date as a string. Now Polar data frame provide 2 different methods: strf time, strp time, that means str format time and str parse time. So you are supposed to use the 2 different methods, provide you all the functionalities which you can use to directly cast date from from string to date or date to string. You will see what I mean with this. So let's go back to this previous example here. So say for example, I'm going to create a temporary data frame. So let's take the first column and as of date, and I'm going to display first as is, and second let's convert that to integer. So date as an integer, and third is I'm going to take the date and I'm going to convert this to a string. So now we have 3 representation of the date: date as an date, or date as an integer, and date as an string. So now when you're working with this kind of data frame, when you have 3 different data type dates representation, you can use these 2 methods what I just talked about. So let's take this first example here. So as of date dot dt, because this was the date, so here you are taking that the date and you're converting to the date, and you are use the function say str format time, and you can convert from date to string. Similarly, if you have a date as an string, you call the string namespace. So again, there are 2 different namespaces or the modules. If you are working with the str, use the str namespace. If you are working with the date, use the date date namespace, and you then simply call this function called strp time or strf time depending on the date format type simply, and then you will have the required results as well. Alright, that's all I wanted to cover in this video from the data type and data type casting perspective. In next follow videos, we are going to continue our discussion and working on the expression itself. So stay tuned, please subscribe if you haven't already. Thank you very much.